Welcome back to the data structure lecture series, and this is the part 5 of our data structure. In this part 5 we are going to build up a program for which we have made an algorithm in the last tutorial. Now I am going to practically do this. Consider an array at the top. This is my array. This is our array and we have to sort this. So first of all I will run my program. Right now I will enter here 50, 10, 80, 30 and 40. And it shows me array before sort is this and array after sort. Now I have to write the program for array after sort after this line. So how can I sort? I have to consider two elements I and j as shown in algorithm. I will write for I equals to 0, I is less than or equal to how many elements? 4, because it starts from 0. Elements are 5. It starts from 0 and up to 4. There are, including 0, there are 5 elements. You can see here 0 is one element, 1 is second element, 2 is third element, 3 is fourth element, and 4 is fifth element, this address. And here we will write I plus plus. Similarly, we will use nested for loop here. We are using nested for loop here because we have to first x should be 0 and j we have to traverse j from 1 to 4. For that I have to use for loop for j because I have to traverse it internally. When I is 0, for when x of I is 0, x of 1 I have to compare same element x of 0 with this and this. So I have to consider j as, if I is 0, j will be considered as I plus 1. If it is 0, j will be 1. If again the increment will be done here, when my first iteration will be completed, this I will become 1 and x of 1 will be compared to x of j. X of j will be that time 2.
I will write for j equal to, it is not 0, it is not initialized to 0, it should be initialized to I plus 1. So I will write j is equal to I plus 1. We have initialized, if I have initialized I as 0, j is next element. If I have initialized I as 1, j is next element as 2. Similarly, so I have written here I plus 1. When I will be incremented, it will be 1. That time j will be 2. If I will be incremented again, it will be 2. That time j will be 3. Okay, because we have to compare 0th element with first element. Similarly, we have to compare first element with second element. Okay, then I will write here j is equal to I plus 1. J is less than or equal to 4 j plus plus. Then I have to see if the value at the 0th position, we have to compare this with each and every element up to the last. This is doing the work that it is traversing from first element to fourth element and comparing with this. So if I am comparing, if x of I is less than or equal to, is less than, if x of I is less than, we will write if x of I is greater than x of j. If x of I is greater than x of j, then in that case I have to swap both elements. I have to declare another variable int temp, temporary variable int temp is equal to, we will store x of I in that x of I, and x of I, we will assign x of j to x of I, x of I is equal to x of j, x of j equals to temp. Okay, what we are doing, what is this part doing here? This is actually the swapping algorithm. If I will find that in this case 10 is smaller than 50, what I am doing, I am initializing a temporary variable temp. I will hold temp x of I. What is x of I and what is x of j? We have to interchange these. I have to write 10 here and 50 here. If I will write 10 here, then how can I get 50? So we have to store this 50 initially somewhere in temp. That is the reason we are using the temporary variable. So it was 50 and we will store this 50 first here, and now I can change the x of I value. So that 50 was stored here, we can now change its value, then we can use this 50 again. I will replace it with 10, and here it is written x of I is equal to x of j. So x of I is equal to x of j. X of j is 10 and we are assigning this temp here, and x of j is equal to temp. X of j is equal to temp. Temp is 50. So it was 50 10, now it is 10 50. This is the swapping algorithm we are using here. Now moving forward, we are done with the program. Okay, we are done with the program. Now what is it doing? What is our program doing? We have to only print now. We have to only print this array now. For printing, we will again use these lines. I will copy and I will print it again. Same array I have to traverse again. Now I will show you. This will give us array after sort. Okay. Here is some error. Basically, we have not initialized this j. Like I have been, I is initialized at the top. We will initialize j here, integer. Now we will run this and enter element. Element is 50, 10, 80, and 30 and 40. 50, 10, 80, 30, and 40. This is our array before sort, and this is our array after sort. You can see the order 50, 10, 80, 30, 40. Here is 10, 30, 40, 50, 80. Okay. Now I will explain the memory map, how it works. This is I. This is j. Initially, I is initialized as 0 and j is initialized as I plus 1. J will be 1. Now, we are comparing, is j less than or equal to 4? Yeah, j is 1, it is less than or equal to 4. Now we are comparing if x of I is greater than x of j. What is x of I? X of 0. Because I is 0, x of I is 50. We are comparing x of I with x of j. So, out of these, if x of I is greater, yes, x of I is greater. So we are in this if statement. So we have to swap this. So this 10 will come here and this 50 will go here. Okay. Now after that we will again go into the increment of j. J will be 2. After j will become 2, now we are here. I is still 0. So 0th element. 10 is to be compared with the second element, that is 80. So x of I, 10 is compared with 80. Here x of I is greater than x of j. No, this time it will not move into the if statement. It will simply go out of this statement. So no swapping will take place and j will become 3. J has been incremented by 1 and it will become 3. After that, when j becomes 3, j is less than or equal to 4. Yeah, j is this 30 right now, and I is 0. X of 0 is 10 and x of 3 is 30. X of 0 is less than x of 3. So no change will take place, no swapping will take place here. 10 will be at its place and 30 will remain at its place. Okay. And again j will become 4 and it is 40 and this is 10. So again no swapping will take place. It will not enter into this if statement. So now it will reach here, and after that now j will not get incremented, I will get incremented because it is the external for loop. And I is less than or equal to 4. Yes, I will become 1. Yes, I is less than or equal to 4. J will become I plus 1 because I is this time 1. J will become 2. Now this element will be compared with this. You can see out of these 5 elements, the element which was smallest has come on the first position. Similarly, now we will take this as first and compare with all these elements. Okay. Similarly, it will move in cycle and I will show you how. J will become 2. Okay, x of I is 50. This 50 is to be compared with x of j. X of j is this 80. This 50 and this 80 is compared, and out of this 50 is smaller, so no swapping will take place. It will not enter into this if statement. It will move here, and after that j will get incremented. J will become 3. When j becomes 3, x of I is compared with x of j. X of I is 10 and x of j is this 30. 10 and 30 is again compared. Sorry, not 10. X of I is this x of 1, that is 50, and this 50 and this 30 is compared, and this time swapping will take place as 30 is smaller than 50. Okay. Now moving again forward, this will become 4. Okay. When this becomes 4, this 30, because it's x of I, this is 1, x of 1 is 30, is compared with x of 4. that is 40, and no change will take place as 30 is smaller than 40. Now again I will get incremented again because internal for loop has been ended again, and now we will give increment to I again. J was incremented internally and I will be incremented externally. So I becomes 2 and J is I plus 1, J becomes 3. Okay, J becomes 3. When J becomes 3, so x of 2, what is x of 2? X of 2 is this 80. This 80 is compared with x of j. X of j is this 50 because x of j is x of 3. This 80 and this 50 is compared. Out of this 50 is smaller, so exchange will take place. This 50 will come here and this 80 will come here because it is entering in this if block. Swapping will take place because x of I was smaller than, because x of I was greater than this x of j. Now again this 3 will become 4 and we are comparing x of 2 because x of 2, x is this time 2, x of 2 is this is 2, x of 2 is 50. This 50 is compared with this 40 now. Out of these 40 is smaller, so again swapping will take place. It will again move in this if block. 40 will come here and 50 will come at last. Okay, now again we have reached the last position. So this time j is not equal, this condition will be false, so increment will be taken place to this I again. I will become 3, j will become 4 because j is equal to I plus 1. Here you can see. Now I is this 3, this 80 is I, and this 450 is this j. Okay, out of these x of I is greater than x of j. This 80 is greater than this 50. Yes, so swapping will take place. This 50 will come here and this 80 will come here. So after that j will be incremented. J will get 5, and but this 5 is conditionally false, false here. So again I will be incremented by 1. I will become 4. When I becomes 4, j becomes 5. Is j, it will get, this condition will get initially false because this will get into false because j is less than or equal to 4 but j is 5. It will come out of this loop and I will get increment, and again this condition I will get incremented, I will become 5, but this time this condition will get false and it will get out of loop and our array has been sorted. This is 10, this is 30, this is 40, this is 50 and 80. You can see 10, 30, 40, 50, 80. Our array is sorted now. This was the algorithm and this was the memory map of our program which was related to sort of arrays. Thank you.